Another special diode types are optical diodes. There are two popular types of optoelectronic devices, lighting emitting diode and photodiode. The light emitting diode or LED is a diode that emits light when biased in the forward direction of p-n junction. So when you connect anode is positive, cathode is negative, then our LED becomes emits light. So schematic and symbols of LED it looks like this one. Physically or can get in the market, it looks like this one or by this type or by this type. So how they identify terminals? The cathode type of for this type of LED lead on right looking from front. From the front side, that is the right side, we can call it cathode terminal. When it gets like this type of LED, the anode is longer lead. So the longer lead becomes anode terminal. When you get it looks like this type of LED near tab, like tab this one, we can call it anode terminals. So LEDs are produced in array of shape and size. So in different colors, in different shapes, we can get LED. So the LED characteristics the same as p junction diode characteristic curve that is forward and reverse. During forward time, higher forward voltage we can get. During reverse time, lower reverse breakdown voltage we can get. So that is the LED characteristics the same as original diode. Application of diode mostly in 7-segment display is an example of LED used for display of decimal digits to count from 0 up to 9 in 7-segment display. So LED display are packages of many LED arranged in pattern, the most familiar pattern being the 7-segment display for showing numbers, digits from 0 up to 9. So 7-segment display we use LED diode. How they construct and how they work LED. When light emitting diode is forward biased, electrons are able to recombine with holes within the device, releasing energy in the form of photons. This effect is called electroluminescence, and the color of the light corresponding to the energy of the photon is determined by the energy gap of the semiconductor. Fabricating the p-n junction using semiconductor of the type known as direct bandgap materials. So the construction or parts of the LED, that is the upper top part is epoxy lens or case, wire port that is with the reflected cavity or semiconductor, wire bond, reflected cavity, semiconductor die, the anode part that is post, and the cathode part, and below that is lead frames. This is the bottom side is flat spot. So this side is cathode terminal, and this type is a C shape anode terminals. So how they work of LED, as I can read it, this is the structure of LED internal parties. It looks like this one. So different colors we get from different semiconductor materials. Look at this table, LED color and voltage drops. So the color infrared type wavelength up to 706 voltage drop less than 1.9 volt. So for infrared, what are the materials semiconductor? Gallium arsenide, aluminum gallium arsenide. If you need lead colors, the voltage drop from 1.6 volt up to 2.03 volt. Materials of semiconductor aluminum, gallium arsenide phosphide are we can give it a red color. So different colors with different semiconductor materials and different voltage drop with also wavelengths. So how to test an LED? Never connect an LED directly to a battery or a power supply. It will be destroyed almost instantly because too much current will pass through and burn it out. LEDs must have a resistor in series to limit the current to a safe value for kick testing purpose. A 1 kilo ohm resistor is suitable for most LED if your supply voltage is 12 volt or less. So remember to connect the LED the correct way. It looks like one. That's the positive of the battery with the resistor from the resistor to the anode side of LED. So from the cathode side of LED back to the negative side of our source battery. LED we can get in three colors. So the most popular type of three color LED has a red and a green LED combined in one package with three LEDs. They are called three color because mixed red and green line appears to be yellow. The diagram shows the organization of three color LED. Note the different lengths of the three LEDs. The central LED, the cathode side, is a common cathode for both LED. The outer LED, anode 1 and anode R, the anode 2, the LED, allowing each one to be light separately or both together to give certain colors. So when you combine red with green, you can get yellow colors combined. So how to get a resistor in the LED? So an LED must have a resistor connected in series to limit the current through the LED. The resistor value R is given by R value becomes V source minus of the voltage of LED, that is voltage drop is the LED over current of LED maximum. So Vs, V supply voltage, VL, LED voltage is value 2 volts. But if you have blue and white colors, we use this VL 4 volt. Current LED, example 20 milliampere mostly. This must be less than the maximum permitted if the calculated value is not available. Choose the nearest standard resistor value which is greater. To limit the current, even greater resistor value will increase the path life, but this makes the LED less bright. So for example, if our supply voltage 9 volt and we have a red LED, that's our red LED we can use 2 volt. So recurring current, that is current LED, we use 20 milliampere mostly, that means 0.020 ampere. So to get the resistor value, 9 minus 2 over 0.2, so our resistor value is 350. But this resistor value, that is not standard type of fixed resistor. So to choose 394, so the nearest greater standard value becomes 394, connect in series with the LED. By this calculation, we can get the value of a resistor. Connect LED in series, let's say when you need different colors in series, how to get the value of R and the drops of the LEDs. If you wish to have several LEDs on at the same time, connect them in series. This prolongs battery life by lighting several LEDs with the same current as just one LED. The power supply must have sufficient voltage to provide about 2 volts for each LED, except for blue and white color have 4 volts, plus at least another 2 volts for the resistor drop. To work out the value for resistor, you must add up all LEDs voltage, and this is for VL. So red, yellow, green are 2 volt drops, 2 plus that is 6 or 3 times 2 volts becomes 2 volt, plus the resistor voltage drop 2 volt that becomes 8 volt. So choose a 9 volt battery minimum So adjust the resistor R to have current 15 milliampere. So our VL becomes 6 volts, real voltage added up. If the supply voltage is 9 volt and the current must have 50 milliampere, so 9 minus 6, that becomes 3, 200 ohm. So 200 ohm is not a standard fixed resistor, so we choose 220 is a standard fixed resistor. So the nearest standard value should be used. So 220 resistor is right with the 3 LEDs. So application of LED, where they apply most. There are many applications for LED such as in display that we look at it 7 segments, digital clock, microwave oven, traffic signaling, display board in railway public places, electronic appliances, stereo tuner, calculator, DC power supply, on off indicator in amplifier, power indicator. So in many we can use an LED like commercial infrared readable machine, barcode reader, solid state video. We use an LED. Optical communications switching application for optical coupling where manual help is unavailable. Information transfer through FOC, image sensing circuit, burglar alarm, railway signals, door and other circuit control system. Just LED has main advantage in the application. There is another important diode called laser diode, which also has got main advanced feature and scope of features. Let us talk about laser diode. In the latter, solar cell, the light-dependent diode, including solar cell, which is a normal p-n junction diode, but has its conduction by the rush of photons, which are converted into the flow of electrons. This is similar to a photodiode, but it has another objective of converting maximum incident light into energy and storing it. The feature below represents the symbol of solar cell. A solar cell has its name and symbol indicating storing of energy through its a diode, the feature of extracting more energy and storing of it concentrated in the solar cell. The construction of solar cell, a p-n junction diode with an intrinsic material in the deletion region is made to encapsulate in a glass. The light is made to incident on maximum area possible with thin glass on the top so as to collect maximum light with minimum resistance. The following figure shows the construction of a solar cell. So sunlight, glass, metal ring, junction, and metal contacts. So this is the output of this. When the light is incident on the solar cell, the photon in the light collide with valence electron. The electrons are energized to leave the parent atom. Thus, a flow of electron is generated, and this current is directly proportional to the light intensity focused onto the solar cell. This phenomena is called photovoltaic effect. The following figure shows how a solar cell looks like and how a number of solar cells together are made. Solar cell panel, it looks like so single solar cell. So the difference between photodiode and solar cell is photodiode works faster and concentrate on switching rather than providing more power as output. It has a low capacitance value. Because of this, also the area of incident of light energy is lesser in photodiode. According to its application, a solar cell concentration on delivering high output energy and storing the energy. This is high capacitance value. The portion is bit slower than photodiode. According to the purpose of solar cell, the area of incident of light is larger than photodiode. There are many applications of solar cells such as in science technology, solar panel for satellite, used in telemetry, used in remote lighting system, in commercial solar panel for storage of electricity, portable power supplies, household uses such as cooking, heating, using in solar electricity. commercial use. A network is for watch, calculators, electronic toys, etc. Some diodes emit light according to the voltage applied. There are two main types of diodes in this category. There are LEDs and laser diodes, what we have seen in the previous. Another type of optical diode is the photodiode. When it's in the LED, from light electrical energy to light energy. But in the photodiode is the reverse. Look, photodiode is a PN junction that convert light energy into electrical energy. It operates in reverse bias voltage. As shown in the figure where reverse current, the reverse light current, it has small transparent window that allow light to strike the PN junction. The resistance of photodiode is calculated by the formula as follows. Resistance of the photodiode, voltage reverse over light reverse light current. That we can get the resistance of our photodiode. So photodiode, as the name implies, is a PN junction which works on light. The intensity of light affects the level of conduction in this diode. The photodiode has a p-type material and an n-type material with an intrinsic material or depletion region in between. This diode is generally operated in a reverse bias condition. The light, when focused on the depletion region, electron-hole pair are formed and flow of electron occurs. This conduction of electron depends upon the intensity of light focused. The feature below shows practical photodiodes. The photodiode, it looks like physically, but the symbol of photodiode, it looks like this one. When the diode is connected in reverse bias, a small reverse saturation current flows due to thermally generated electron-hole pair. As the current in reverse bias flows, due to minority carriers, the output voltage depends upon this reverse current. As the light intensity focused on the junction increase, the current flow due to minority carriers increase. The following figure shows the basic arrangement of photodiode. So it looks like this one. So the photodiode is connected in the reverse by P material with the resistor with the negative of the battery and material to the positive. So photodiode is encapsulated in a glass package to allow the light to fall onto it. In order to focus the light exactly on the depletion region of the diode, a lens is placed above the junction, just illustrated in the above. Even when there is no light, a small amount of current flow, which is termed as dark current. By changing illumination level, reverse current can be changed. So the advantage of photodiode as main advantage: low noise, high gain, high speed operation, high sensitivity to light, low cost, small size, long life term. So where they apply those photodiodes? Can apply in many character detection. Object can be detected visible or invisible. Used in circuits that require high stability and speed. Used during demodulation. Used in switching circuits. Used in coders. Used in optical communication equipments. Another diode of such kind of is solar cell. It's termed as cells of its diode. Again, in the detail, you can see it. So we can use it to detect any object. We can alarm purpose use it a photo diode. Let's see a laser diode. A laser diode is another popular diode for its kind. This is an optical diode which emits light but with stimulated process. The name laser implies light amplification by stimulated emission of radiation. So the symbol of laser diode, it looks like this one. Principle of laser diode: whenever a photon is incident on an atom, that atom is exited from a lower energy state to a higher energy state, and two photons are released in this process. Actually, an atom can generally stay at this existing state for 10 raised negative 8 seconds of time. So in order to achieve amplification during this existing process, the atom is made to be placed in another state called metastable state, which is below the higher energy level and above the lower energy levels. An atom can stay in this metastable state for 10 raised negative seconds, while the atom gets to the lower state. From this, two photons are released. If more number of atoms are there in the existing state period to the photon striking the atom, then we have the lasing effects. See population inversion of laser diode. In this process, we have two terms to understand. Having more number of atoms at metastable state than the lower energy state or ground state is called as population inversion. Then energy that leads the atom to send from a lower energy state to a higher energy state to achieve the population inversion is called as pumping. This is optical pumping. So advantage of laser diode. So in practical laser diodes looks like this one. There are many advantages of laser diodes such as power used by laser diodes is much less, higher on-off switching speed, more compact, less expensive. They are cheaper than laser generators, less chance providing ethical shocks. So where they apply and what are the advantages? There are few disadvantages such as more divergent ray and hence quality is not so good. Their lifetime is less compared to LED, prone to damage during unstable power supplies. The application of laser diode, pump laser and seed laser in optical data storage device, used also in laser printer, laser fax machines. You can use a laser diode in laser pointers in barcode readers. There are used in DVD and CD drivers, in HDVD and Blu-ray technologies. Has many industrial purposes such as heat treating, cladding, sim welding, etc. Has got many uses in communication technology such as data link and transmissions. So this is all about the diodes. Thank you for your attention. If you have any comments or questions, don't forget put in comment box. Thank you again.